Let us now understand how the Huygens principle explains passage of light through prism, lens and concave mirror. So we first start with prism. So you have a front of light coming in. So this is the front of light coming in. It encounters the prism. Now notice that this bottom will pass through the maximum thickness of glass. So the glass is this thick here of the prism. So therefore this front gets slowed down. So therefore it covers only this much distance. Whereas this front encounters very small thickness of glass. So it travels faster here. In the glass it will slow down and then it will travel faster again. So this top front is going to travel faster than the bottom front just because it goes through less amount of glass. So here the speed of this front will decrease in the glass. So therefore once this front of light passes through the glass, it gets bent like this. So this is for the prism. Now for the lens. Now in the lens you see that this is the front of light coming. Now the thickness of the glass is maximum at the center. So this will travel slowest through the center, whereas the top part and the bottom part of the wave front, this and this part, will encounter very thin glass here. So this is much thinner than the center part. So since the speed of the light is going to decrease while passing through the glass, so this bottom part or the central part here, this central part is going to experience the maximum delay. So therefore this passes fast, this bottom passes fast, this top part passes fast, and therefore you see a curve when the light front passes through the lens. So this curve is essentially pointing towards the focus. So now we come to concave mirror. So again you have this front. Now here according to Huygens principle, what you do is for the next front you take a point here and then you draw a spherical part. You take a point here, you draw a spherical part, you take a point here, you draw a spherical part, and then you take the maximum of this and draw another front. Now this is the spherical part which is touching the concave mirror. So once it touches the concave mirror, it is a spherical part. So this spherical part, just the sphere remains. So the normal front vanishes because you are blocking the light here. So all these fronts are not coming. Only the spherical front comes in and then it gets reflected back. So similarly another spherical front would be right here, and then there will be spherical fronts right here. So you can see by the Huygens principle, this thing is getting, the spherical front is getting focused or going to the focus. Now we talk about the Doppler effect. Now the Doppler effect is useful for astronomers. It helps them find out whether two galaxies are moving away from each other. So the fundamental idea is this. Now there is a source which is emitting waves. So the source emitting waves is, say, moving away from the observer. So this could be the case, for example, you are standing on Earth and the source of light is some galaxy. Now this galaxy might be moving away from us. So then the successive distance between the wave fronts is longer at the end of the observer than it is at the source. So standing on Earth, we will see that the distance between wave fronts is longer because the source is moving away from us, and this is called the Doppler effect. Now the increase in wavelength, so this increase in wavelength because the source is moving away from us, is called the redshift. Now in case the source is moving towards us, then the astronomers call this blue shift. So red shift is when the source or the galaxy or the star which is emitting the wavelength is moving away from us, you call it red shift. If that galaxy or star which is emitting the light is moving towards us, we call it a blue shift.